Okay, we're going to be dealing with the first several sections of Chapter 7, which all pretty much are related to graphing, which I thought would be good to do in one big kind of lesson. I'm going to start from the very basics, and then we'll work our way up with that. If we look at something like x equals 4, and I don't remember if you've seen this before on basic number lines, but if you just wanted to plot a single number line, you would have like 0, 1, 2, and then 4 right here. And you would just plot a point, right? And you'd say that's where my x is. Similarly, if you had y equals 3, you'd have a number line. Again, you'd have 0, 1, 2, and then you'd have a 3, and you just plot a point, and you'd be like, that's it. When we start dealing with equations with more than one variable, however, it's important that we find another way to visually demonstrate this. So basically what they did is we're going to make an ordered pair out of it. So an ordered pair is anything of the form x comma y. So that's an ordered pair. We're going to make an ordered pair 4, 3. So that's our x and our y, right, put into the ordered pair 4, 3. Then you can think of it as taking the x number line, if you will. So here's the x axis, and this is basically what we're going to do, the same thing with the number line. And here's our y axis. I'm going to write it down here. And instead of just here, as we know, if we start with the origin and we move towards the left, we get negative numbers, and when we move towards the right, we get positive. Well, that's going to stay true for the x-axis, which is still horizontal here. If you start from the origin and you go to the right, you get positive. You go to the left, you get negative. With the up and down, which is going to be our y-axis, which is going to correspond to this right here, if you go up, it's positive, and if you go down, it's negative. So if we wanted to graph this point, then we're going to use the same concepts that we used on this number line. We simply go over 4 because that's what our x is, and then we go up 3 because that's what our y is, and then bam, there's our point. And whenever we plot a point, we want to be sure to label it. Just to be clear, if we talk about this thing, this is the graph of 4, 3, like the point. But to be specific, it's the point that we're talking about. That's the graph. The whole thing we would call a Cartesian coordinate system. So the whole thing, which is the graph, the x and y axes, and everything you see here is the coordinate system, whereas the graph just responds to this point. Again, you'll see, like, if you have a graph of a line, you'll have a line on there, but the whole thing using the coordinate system is the Cartesian coordinate system. So from there, we can talk about, before we go on to the next section, we can talk about quadrants. So if this was like a mini representation of our Cartesian coordinate system, and we wanted to talk about quadrants, we label this one 1, this one 2, this one 3, and this one 4. And that's just kind of the standard way that we use to label them. And we can talk about what those coordinate systems, what do these quadrants mean. So if we have an ordered pair in this first part, it's going to be a positive and a positive. So this is kind of like my shorthand for understanding that it's positive, positive. Here, of course, you're going to be moving towards the left on the x-axis and up on the y-axis, so that's going to give you a negative and a positive as far as your ordered pair goes. And here you're going down to the left, so you're going to have negative, negative. And here you're going down and to the right, so you're going to have positive, negative. And that's just like a quick idea of, like, you should know some of the properties of points just based on where they are in the graph and their ordered pairs. For there, the next thing to think about is something called x and y intercepts, and I'm going to introduce that through the idea of some equations for lines. So anything of the form anything of this form is going to be called standard form. So we call this standard form. And it just looks nice and is pretty standard. The nice thing about this is that if we ever wanted to know what x and y intercepts are, then they're easy to solve. So first of all, what are x and y intercepts? X and y intercepts, so an x-intercept is when your y coordinate is 0, and your y-intercept is whenever your x-intercept is 0. And you'll see this on the graph, and it'll make a little more sense when we do an example. So here's an example of something in standard form. If you had like 3x plus 5y equaling 15. Say you had this equation. This is an equation of a line. And if you want to figure out what x is, so your x-coordinate is what x is when your y is 0. Well, that's pretty simple because then you just substitute in a y equals 0 into this equation. So you're left with 3x equaling 15, and you get x equals 5. So if we wanted to graph that over on this other side, and this technique will be known as kind of rapid. This is a rapid graphing of a standard form equation. So then we want to know what our y-intercept is. Well, our y-intercept is when our x is 0. So if we plug in a 0 for x, then we're left with the equation 5y equaling 15, so y equals 3. So it's kind of funny because we're just solving for straight up variables here, but technically the x-intercept, if you wanted to write that as a point, would be 5, 0, because it's when your y is 0. And here, similarly, it's going to be 0, 3. So we know these 2 points now, and we can plot these 2 points on the graph. So we're going to go over 5, and we're going to go up 3. So once you have 2 points on a graph, of course, there's only one line that can officially go through 2 points on a graph. So this is a rapid graphing of the standard form. You can label this as, 3x plus 5y equaling 15. That's the equation for this line that represents this line. So this is the graph of that equation, and remember, this whole thing is a Cartesian coordinate system. So from there we can start talking about the idea of what slope is, because we have a given graph. So I'm going to kind of work backwards this way, and then give you an equation that has slope in it, and then we'll graph it on that. So slope, some of you may learned this before, and you think of rise over run. And it's totally acceptable if you think about it this way. A more mathematical way of thinking about it is the change in y over the change in x. These are deltas, which in math almost always refers to change in. So if you have 2 points, you can algebraically define the change in y as 1 point minus the y in another over the x in 1 point minus the x in the other. Because remember, when you take differences, that kind of gives you an idea of change. Visually here, it's how much up you have versus how much down you have. So if you think about it graphically. So here we could do it visually. We could say, okay, we want to know our rise over run. So we could go 1, 2, we know we go down 3, so our rise is -3, and how far do we go over? We go over a positive 5. So if we wanted to move from one point to the other, we would do so by, if we moved from this point, we'd go down 3 and over 5. So that is going to be the idea of our slope. If you look at change in y over change in x, we can take our first point, say this one, and what's our y of this first point? 0. Minus, and then we have 3, and then our x for this point is 5, and then minus 0, which actually gives us the same answer, which is what we wanted. We end up with -3 over 5. So this is the slope, and you can see these are the same. You can either think of it a little bit more graphically, and it's important to be able to pull a slope from a line on a graph, or you can also think about it in terms of algebraic, which is also important. Okay. So coming from the idea of slope, a lot of people like to